Lesson 5.3, Translations of Sine and Cosine Graphs. Objectives. Students will use the functions of the form f of x equals c plus a sine bx minus d and f of x equals c plus a cosine bx minus d in order to correctly graph sine and cosine graphs when translated. So you notice that the only difference here between what we were doing before is the plus c at the beginning and the minus c in the parentheses at the end. The a sine bx and a cosine bx are what we dealt with last class. So let's see what happens when we add the small number to the outside of the graph, where the c was on the objectives. So I'm going to graph f of x equals sine x in red, and you've seen that graph lots of times, so I'll just put it right there. And f of x equals 1 plus sine x in blue. And in order to do that, I'm going to go ahead and make a little table where I have x, sine x, and 1 plus sine x. So the x is going to be this first column here, and the y is going to be this last column here. This middle column is just going to help us figure out what the other two values are. So the first x we're going to plug in is 0. And sine of 0, we can see here over on the graph, sine of 0 is 0. Okay, and 1 plus that is 1. So I put a dot at 0, 1, because those are the x and y coordinates. Then I plug in x is pi over 2, because we always use pi over 2. So pi over 2 is here on the graph, and sine of pi over 2 is 1, and 1 plus that is 2. So 1, 2. Pi over 2, 2, I'm sorry. Then next we put in pi. Sine of pi is 0. Okay, and 0 plus 1 is 1. So this is pi 1 is the next point. Then we put in 3 pi over 2. 3 pi over 2, the sine of that is negative 1. And we put 1 plus that is 0. So we have 3 pi over 2, 0. And then 2 pi, sine of 2 pi is 0. And 1 plus that is 1. So hopefully you can see the pattern now. It's going to look like there, and going the other way, the other period is going to be there. And what happened to those two graphs? So all I did was I took the red graph and I moved all the points up 1. I moved it vertically 1. And that's called a vertical translation. Now I want you to notice down here that if I have the 1 in front, so 1 plus sine x, it's the same as putting the 1 behind, sine x plus 1. So let's see what happens when we add something not outside the parentheses, but inside the parentheses with the x. So this time I'm going to use cosine. So I'm going to graph f of x equals cosine x, and f of x equals cosine of x minus pi over 2. And you notice this is different because this pi over 2 up here is inside the parentheses with the x. So that means we have to do the x minus pi over 2 before we do the cosine. So same graph, I'm going to put the cosine on there. Then I'm going to go over here to the chart. Remember, this is my x coordinate, this is my y coordinate. So I'm going to start with 0. X is 0. 0 minus pi over 2 is minus pi over 2. So here at minus pi over 2, the cosine is 0. So 0. So I put a point at 0, 0, because those are the x and y coordinates. 0, 0. Okay. Then I plug in pi over 2. X minus pi over 2 is 0. Okay. And the cosine of 0 is 1. So at pi over 2, my point's at 1. Then I put in pi. Pi minus pi over 2 is pi over 2. Pi over 2, cosine of pi over 2, we can see right here, cosine of pi over 2 is 0. But my point is pi 1. So pi 1 is right there. Sorry, that should be 0. This should be a 0 right here. And make that note. I'm not going to change it. Make that note. This should be a 0. 3 pi over 2. 3 pi over 2 is minus pi over 2 is pi. Cosine of pi is negative 1. Negative 1 plus 1 is negative 1. I'm sorry. Negative 1. So we have 3 pi over 2 and negative 1. And then finally we have 2 pi. 2 pi minus pi over 2 is 3 pi over 2. And the cosine of 3 pi over 2 is 0. So I plot 2 pi 0. And hopefully you can see the pattern there. And you see what happens there is instead of shifting to up 1, or up pi over 2 in this case, I didn't shift up, I shifted to the right. So that's called a horizontal translation. But I'm not going to use that term very much. I'm going to call it a phase shift. Okay, that's the term for a horizontal translation, is a phase shift. And you notice that it shifted pi over 2 to the right, which was interesting because negative usually means to the left. So when you're dealing with phase shifts, you have to remember it goes the opposite way. So it's the opposite sign of whatever you have in the parentheses with the x. And I want you to be careful down here, look down here, the cosine of x minus pi over 2 when it's in parentheses is not going to give you the same thing as a cosine of x minus pi over 2. Without the parentheses. Without the parentheses, this is going to be a vertical translation. So just to review everything we know so far about the full functions. We know that f of x equals d plus a cosine, that could be a cosine or a sine, bx minus c. We know that the a in this equation tells us the amplitude, and the amplitude is equal to a. We know that the b is going to help us get the period, but the period is not equal to b. The period is equal to 2 pi divided by b. We know that the d is going to give us the vertical translation, because the d is on the outside of the parentheses added. We know that the c is going to give us the phase shift, and the minus sign in front of the c lets us know that this is going to be opposite sign than what it would normally be. So let's graph an example, and let's graph an example that has all 4 elements to it. So I want to graph y equals negative 2 cosine of 3x plus pi, in parentheses, plus 1. I want to graph that over 2 periods. So I'm going to do that by making this chart. Actually, the first thing I'm going to do is I'm going to write down all 4 parts: the amplitude, the period, the vertical translation, and the phase shift. The amplitude, remember, is a, so that's this 3 right here. I'm sorry, that's not the 3, that's the period. Amplitude is this negative 2 out here. So for amplitude, negative 2. The period, you would take 2 pi divided by b. b is in this case 3, so we do 2 pi over 3 is the period. The vertical translation is what you add outside the parentheses, so that's 1. And the phase shift is what's inside the parentheses, but it's opposite sign. So this is positive pi, so the phase shift is negative pi. And I'm going to make, this is how I want you to do all the problems, by the way. You should always start by writing the amplitude, period, vertical translation, and phase shift. Then you should write this chart. You should keep your chart blank and fill it in with the numbers that are appropriate for yours. First column here is x prime. That's going to be the x coordinates if I did not have a phase shift. Then x, that's going to be the x coordinates after the phase shift. Y prime is the y coordinates before the vertical translation, and y are the y coordinates after the vertical translation. So the first column I'm going to fill in is y prime because I get that from the amplitude. Remember, the pattern is always amplitude 0, negative amplitude 0, amplitude 0, negative amplitude 0 for cosine, and 0, amplitude 0, negative amplitude 0, amplitude 0, negative amplitude for sine. Okay, so it's just a up and down crossing 0 in between. Only cosine starts at the amplitude and sine starts at 0. So since the amplitude is negative 2, I'm starting at negative 2. So it's negative 2, 0, positive 2, 0, negative 2. Okay, we're always going to do those 5 points. Now for the x prime, I have to use the period to get the x tick marks basically on the graph. First one's 0, the last one is the period, which is 2 pi over 3. I have to divide that into 4 equal parts, so I multiply it by 1/4 to get this box, 2/4, or which is the same as 1/2, to get this box, and 3/4 to get this box. So 2 pi over 3 times 1/4 is gonna, if I multiply it out, is gonna give me 2 pi over 12, which simplifies to pi over 6. 2 pi over 3 times 1/2 is going to give me 2 pi over 6, which simplifies to pi over 3. And 2 pi over 3 times 3/4 is going to give me 6 pi over 12, which is pi over 2. So now I have those. Now I have to account for the phase shift and the vertical translation. Okay, let's do the phase shift first. I'm going to take this phase shift, so I'm going to multiply every single one of the, I'm sorry, I did not multiply, add the phase shift to all of these numbers. So it's negative pi. And remember, you have to use common denominators when you add fractions. Let's start with the 0. 0 plus negative pi is negative pi. Pi over 6 plus negative 6 pi over 6, that's what's going to give me the common denominator, is negative 5 pi over 6. Pi over 3 plus negative 3 pi over 3 is going to give me negative 2 pi over 3. Pi over 2 plus negative 2 pi over 2 is going to give me negative pi over 2. And 2 pi over 3 plus negative 3 pi over 3 is going to give me negative pi over 3. So those are going to be my x coordinates for my dots that I'm going to draw. And notice the difference between the first column and the second column. I mean, the first row and the second row, and the second row and the third row, and the third row and the fourth row, and the fourth row and the fifth row. Every one is pi over 6 apart. And that holds true because we added the same thing to every single number for x as well. So we know how far apart to make our tick marks. Now y. That's where I take y prime and I factor in the vertical translation, which in this case is plus 1. So all I have to do is add 1 to every single number. That's going to give me negative 1, 1, 3, 1, negative 1. So once you have those that chart completely filled out. Now you can go ahead and draw the graph. So I've carried over the graph. Remember I told you the tick marks would be pi over 6 apart, and that's what I did. I drew the tick marks pi over 6 apart, and I put my whole chart there. Only I'm going to ignore x prime and y prime because x prime and y prime ignore the translations, and I don't want to ignore the translations. I have to graph the graph with the translations, so that's what I'm going to do. So I just plot these points: negative pi, negative 1, negative 5 pi over 6, 1, negative 2 pi over 3, 3, negative pi over 2, 1, and negative pi over 3, negative 1. Only problem I have now is that is only one period, and I needed to graph 2 periods. So I'm just going to continue the pattern. So I go over 1 more pi over 6, and that's going to bring it back to 1. 1 more pi over 6, that goes up to 3. 1 more pi over 6, that goes down to 1. And 1 more pi over 6, that goes down to negative 1. And I know that's 2 periods because I started at negative 1. When I got back to negative 1, that was 1 period. And when I got back to negative 1 again, that was 2 periods. So I trace it out, and there is the graph that you have to draw. Okay, just to sum up what we have. Okay, that was the chart, and that's how I've had it all filled out. Remember that the column of y prime came from the amplitude, and you learned that in lesson 5.1. The column of x prime came from the period. That was from lesson 5.2. To find x, all we did was we used the phase shift, so we took x prime plus the phase shift, and to find y, you just did the vertical translation, or y prime plus the vertical translation. So let's go ahead, and on the next page I'll show you the work, and we will be done.